Let's explore another important property of binary operations called the associative property. A binary operation is said to be associative if the way we group the elements does not affect the result. In simple terms, if we have three elements A, B, and C, then the operation star is associative if the result is the same, whether we group the first two elements or the last two elements. Notice that in this property, we're not changing the order of the elements, like we did in the commutative property. Instead, we're changing the grouping by simply moving the brackets. Let's look at an example with addition of real numbers. Take these three numbers. If we group the first two numbers, we'll get 5. Now 5 plus 4 is 9. But what if we group the last two numbers instead? We'll get 7. Add the 2, and we'll get the same 9. This means that addition is associative because we get the same result whether we group the first two numbers or the last two numbers. It's the same for multiplication. If we should multiply these three numbers, we could multiply the first two numbers to get 6, then times 4 gives us 24. Or we could multiply the last two first and get 12, and 2 times 12 gives us the same 24. So multiplication is also associative, since it doesn't matter if you multiply the first two or the last two before multiplying by the third number. Now, subtraction and division are not associative. Take, for example, 12 minus 6 minus 2. If we group the 12 minus 6 first, we'll get 6, and 6 minus 2 equals 4. However, what if we group 6 minus 2 first? We'll get 4. But 12 minus 4 is 8, a different result. Hence, we can clearly see that subtraction is not associative. Division is not associative for the very same reason. If we group the first two numbers, we'll get 2, and 2 divided by 2 is 1. However, if we group the last two numbers, we'll get 3. Now 12 divided by 3 is 4, a different result. So division is not associative, since grouping the first two numbers give a different result from when the last two numbers are grouped. Let's try a problem. A binary operation star is defined as shown. Evaluate the following, then determine whether the operation is associative. In part A, we need to calculate the bracket first. So replace A with 1 and replace B with 2, and we get 1 plus 2 plus 3 times 1 times 2, which is 3 plus 6. So the bracket works out to be 9. So now we need to find 9 star 4. To find 9 star 4, we replace A with 9 and replace B with 4, and we get 9 plus 4 plus 3 times 9 times 4, which is 13 plus 108. That's 121. Let's now move to part B in the question. Again, we need to calculate the bracket first. So replace A with 2 and replace B with 4, and we get 2 plus 4 plus 3 times 2 times 4, which is 6 plus 24. So the bracket works out to be 30. So now we need to find 1 star 30. To find 1 star 30, we replace A with 1 and replace B with 30, and we get 1 plus 30 plus 3 times 1 times 30, which is 31 plus 90. That's 121. The same answer we have for part A. So grouping the first two numbers gives the same result as grouping the last two numbers. Hence, the operation is associative. Pause the video and solve this final problem. A binary operation star is defined as shown here. To answer part A, we need to calculate the bracket first. The bracket simplifies to 5, and 5 star 4 is 6. Now to answer part B, we need to group the last two numbers and see if the result is the same as the answer we have for part A. So this time we'll group 1 and 4. 1 star 4 is negative 2. So now we are calculating 3 star negative 2, which is 6 minus minus 2, which is 8. A different result from what we calculated in part A when the 3 and the 1 were grouped. So the operation is not associative. Thanks for watching. In the next video, we'll take a deep dive into the distributive property of binary operations. Don't forget to like, share, and subscribe to our channel. See you soon.